So here find the question number 21. How many 4-digit positive integers have at least one digit, that is 4 or 7? So this is actually a very simple question, right? First of all, so here how to solve this question? So just check how many 4 digits numbers are there, then you just reduce or you just subtract the numbers that the numbers which doesn't have 4 or 7. Okay, so how many 4-digit numbers are there in total, starting from 1000 to 9999? So here in the first place, in the ones place, how many digits can come? So the maximum value is 9999, right? So here in the ones place, all 0 to 9 digits can come, and in the second place, sorry, in the tens place again all 0 to 9 digits can come. In the third place again all 0 to 9 digits can come, and in the thousands place what all numbers can come? Except 0, every number can come, right? If it is 0, then only it will be a 3-digit number, right? It will become a 3-digit number. So except 0, all others numbers can be there in the thousands place, right? So 9 into 10 into 10 into 10. So it will be 9000. That means in total there are 9000 numbers. And now the numbers without 4 or 7. So what are the numbers without 4 or 7? So here in the first case, the numbers without 4 or 7. So look here, total 10 numbers can come, and we need to exclude 4 or 7, right? So how many numbers will be there? It will be 8 numbers, right? And in this place also again 8 numbers, here also again 8 numbers, but here how many numbers? Total 9 numbers can come in the thousands place, but excluding 4 or 7, so 9 minus 2, it will be 7 numbers can come, right? So 7 into 8 into 8 into 8. Okay, so what value you are getting here? When you multiply this 7 into 8 into 8 into 8, it will be 3584, right? 3584. So just reduce 9000 minus 3584, then you will be getting what value? You will be getting, it will be option B, 5416. Option B will be our answer. That means, so here that means the numbers, total 9000 numbers are there, and when you reduce the number without 4 or 7, that means the numbers without 4 or 7, it is 3854 numbers are there. So 9000 minus 3584, sorry, 3584, then you will be getting 5416. That means the total numbers with either 4 or 7, it will be what? Not without, the total numbers that have at least one digit, that is 4 or 7, it will be 5416. Question number 22. What is a reminder when 110 into 111 into 112 into etc. into 119 is divided by 481? So how to solve this question? So what is the reminder they are asking? So I am factorizing this 481. When you factorize this 481, it will be what? It is 11 into 13 into 37, right? 11 into 13 into 37, you will be getting the value as 481. When you factorize it, you will be getting 11 into 13 into 37. So all these three numbers are what? They are actually prime numbers, right? And now here 110 you can write it as 11 into 10, and 111 you can write it as what? 37 into 3, right? 37 into 3. And 117, how you can write? You can write it as 13 into 9, right? 13 into 9. So here, look here, 110 is what? 11 into 10. That means 11 into, instead of 110, I am writing 11 into 10 into 111. Instead of 111, what you can write? Instead of 111, you wrote, I can write it as like 37 into 3, right? 37 into 3 and into 112 into 113 into etc. into 117. How you can write? You can write it like 13 into 9, then into 118 into 119, the whole divided by 481. 481, how you can write? It is 11 into 13 into 17. So 11 got cancelled, 13 where? Yeah, 13 got cancelled, then 37, right? 37 got cancelled. Now from this it is understood that the multiplication value of 110 into 111 into 112 etc. up to 119 is easily divisible by 481. That means your remainder will be 0. Our answer is option D, it is 0. Okay, now consider question number 23. Which of the statements is or are correct? First statement, if x is a natural number which is a perfect square, then the number x plus root x must end in 0, 2 or 6. So how to solve it? So what do you mean by a perfect square? So can you give some examples of perfect square? For example, look here, number 9, is it a perfect square? Exactly, because it is actually 3 square, right? That means, so what is a perfect square means? So in simple you can say that when you multiply a number with that number itself, then you are getting a value, then that value will be a perfect square. For example, 4 into 4, that means 4 square, it is 16. Okay, or the square value of any number, that will be what? That will be the perfect square. So 4 square, it is 16. 8 square, what is 8 square? It is 64. 9 square, it is 81. What, right? 11 square is what? 11 square, it is 121. So in the first statement it is saying that if x is a natural number, what is a perfect, which is a perfect square? X is a natural number which is a perfect square, then the number x plus root x must end in either 0, 2 or 6. So for example, consider a perfect square 16. 16 is a perfect square. 16, x is perfect square. So x plus root x. So root of 16, it is what? It is 4. Then 16 plus 4, what value you are getting? It is 20. So it is ending with 0. And consider the perfect square 25. 25 plus the root x. So 25 plus root 5, root 25. Root 25, it is 5. So 20 plus 5, again you are getting 0, right? So consider the perfect square 11, right? 11, you know the square of 11 is 121. So consider the perfect square 121. So 121 plus root of 121, it is 11. So 121 plus 21, what value you are getting? So it is 132. So here you can say that the number is ending with either 0 or 2 or 6. Yeah, there are, if you are looking onto the examples, you will be getting the value for 6 also, right? So that means the first statement is correct. And now coming to the second statement, the number 10 square 10 raised to n minus 1 is divisible by both 9 and 11 for every even natural number n. That means if you are substituting n value, if you are substituting the even natural number for n, then that number is divisible, then that 10 raised to n minus 1 is divisible by either 9 or 11. So let us check. So consider n as 2, then 10 raised to 2 minus 1. 10 raised to 2 is what? It is 10 square is what? 10 raised to 2 minus 1. 10 square is 100. 100 minus 1, it is 99. So 99 is divisible by both 9 and 11. Then 10 raised to 4, right? 10 raised to 4 minus 1. 10 raised to 4 is what? It will be 10,000, right? 10,000 minus 1, then it will be 9,999. Is 9,999 divisible by 9 and 11? Of course it is divisible by 9. And if you are looking onto the sum of the odd numbers minus sum of the digits in the odd places minus sum of the digits in the even places in 9,999, then you are getting the value is 0. That means this number is easily divisible by 11. Okay, so here we check the divisibility condition of, you just substitute the value of n as any even number, and then you will be getting a value, and just check for the divisibility condition. If it is divisible by both 9 and 11, yeah, that number it will be divisible by both 9 and 11. That means the second statement is again correct. So here both the statements are correct, then our answer is what? Option C, both 1 and 2. Now consider question number 28. So this question is actually a beautiful question, right? So yeah, look here. Observe that the 3 can be expressed as the sum of 2 or more natural numbers in 3 different ways. So here it is saying that the number 3 can be expressed as the sum of 2 or more natural numbers. Sum of 2 or more natural numbers can be expressed in 3 different ways. That is 1 plus 1 plus 1, 2 plus 1, 3, 1 plus 2. That means 3 can be expressed in how many ways? 3 can be expressed in 3 different ways, right? And likewise, the number 4 can be expressed in 7 different ways, right? So the 4 can be expressed in 7 different ways. And the question is what? In how many such expressions are there for 2018? So here 3 can be expressed in 3 different ways and 4 can be expressed in 7 different ways. So from these two you can actually make a pattern. So what is actually that pattern? So look here, so here you can write the 3 value as what? 3 value you can write is like 2 square minus 1. Am I correct or not? 2 square minus 1 you are getting what? You are getting 3, right? So here 7, how you can write? 7 you can write it like 2 cube minus 1. 2 cube minus 1, you will be getting it as 7. That means here 3 can be written as 3 square minus 1 ways, and 4 can be written as 3 can be written as 2 square minus 1 ways, and 4 can be written as 2 cube minus 1 ways. That means n value can be written in how many ways? N value can be written in n value can be written in how many ways? N value can be written in 2 raised to n minus 1, 2 raised to n minus 1 minus 1 ways, right? 2 raised to n minus 1 minus 1 ways, 2 raised to n minus 1 minus 1 ways. So here, how many such expressions are there for 2018? So here n value is 2018. That means 2 raised to n minus 1 minus 1 ways. That means 2 raised to 2018 minus 1 minus 1. That is 2 raised to 2017 minus 1 ways. So our answer is option C.